Hello and welcome. This is Let's Code TimeTrack, episode number 3, Preliminary Design. In this episode, I start with the program and data design based on the scenario analysis of the last episode. Data structures. Data structures are core part of the program, so much so that I like to start with them and then build a program around these. I also like the elegance of SQLite databases, so the data is stored in one such file. The path is specified by the user. The data is mainly revolved around tracking. We have the tracking ID, which is just an ID in the table, the project name, a start timestamp and a stop timestamp, which defines a time range. This could be a one-table database, but that would be hard to manage manually, for example, with a SQLite Explorer. So instead of stuffing every project in one table, I create a new table for each project referenced by the project ID. So one table is a general projects table that contains an automatic ID, the name of the project, which can be changed, and two flags if it's faded and archived. And then each project has a separate table, and the name of the table includes the project ID. And these tables contain the start and end timestamp for the tracking periods. I was thinking about making it possible to track time without a project name, but that doesn't make much sense. So one project will be auto-created on setup, and it will be called unspecified. This project will not be archivable, but can be faded when other projects are not around. Data structures number 2. Besides the project tables, there is also a general states table that stores the last selected project, which is used at program startup. This is a key value table which has a unique key. This is basically a simple generic string-to-string map in a table form. The key for the last project is last project, and the value is the PID. This concludes the data stored on the disk for the user. There is also the configuration file, which is stored based on the host system, and this stores the location of the data file that the user specified. If the data file is set, the path, the application uses it to load this and the status at startup, and as it runs the setup routine that asks the user where the data file should be placed. Because I'm using the Qt framework, I use the QSettings class to store these configuration options. This keeps the application nicely portable. Modules. This is a very quick overview of the separate modules that I will create with the application. First is the startup module, which will check for the single instance being of the application, and it will also set up the communication with existing instances if a command is required. Then there is the shutdown protocol. The shutdown sequence really is about stopping all running timers, storing the current state, the current data, and cleaning up any IPCs and data that's dangling around. Then there is the sys-tray, which is the permanent UI that will be showed in a sys-tray, and will enable the user to summon the various widgets that are part of the application and start and stop the timer and change the project. The config module will store the database location, and it will have this config widget, which basically just one line containing a path entry field. The data module is a SQLite table abstraction. It will implement the data structures that I showed here in these two slides, and it will create abstract interfaces for the rest of the application to start and stop tracking and change projects. The analytics module is a widget that uses the data store to aggregate the data and create charts for it. So create summary charts for a project or a time sequence or multiple projects, and to create the punch cards. The project manager will enable to create new projects, to fade projects, to archive projects, and to rename projects. This will be a widget with a table, with a list in it that lists the projects, and then a few controls on the sides. Nothing too complicated, but enough to be a very powerful project manager for the time tracking. And then is the time tracker, of course, which will just manage the start and stop sequences of the time tracking and make sure that the time tracking works. It's basically a combination of the systray command for tracking time, the IPC communication method for controlling the start and stop tracking parts, and it also communicates with the project manager and asks which is the current project which I should track, and then it talks to the database and says, okay, update this timestamp or this tracking sequence in the database. Roadmap. So how do we go about this? I could now go on for videos and videos and videos about designing the entire application, but that probably won't work. Over designing will just waste time, and I will just change it later on. So what I will do is I will create a set of prototypes in the next few videos for each of these components that the application has. And I will experiment with the technology, with the framework, implementing a draft for all these parts. Then I will architect the inner data module and communication interfaces, and then I will build an object communication flow based on the scenarios. I will very much encapsulate the objects so they will have clear interfaces through which they communicate with each other. Then I will narrow down the roadmap and implement the final application using test cases, and then building the modules and connecting them. Thanks for watching. The next unit will move on to prototypes, and there will be some coding finally. Have a good day and goodbye.